Hello everyone. In this video we are going to just look forward with the second rule of differentiation, which is called the product rule. Well, in product rule, what I would like to tell you, this is a very important rule, and we use a lot in calculation of calculus and differentiation. So let us straight away go ahead and see how we can use product rule, what is the formula, and few of the examples which will make life easier. So for the product rule, what we are going to look forward first is that what is the formula? Like, how do we calculate the product rule? Just note that currently what I'm doing is that I'm using the prime notation. I'm using the prime notation because otherwise it would be too long in order to write it in Leibniz notation, that is dy by dx. So the product rule is something which goes like this. So if I get a function f of x, and because we are doing a product, obviously there would be another number and we call it as g of x, right? So what we are going to do is that we can write this as, we first take the derivative of this first part. So we use the prime notation f prime of x, right? Then we put a dot, that is the multiplication sign, and then we just use the second variable, that is g of x, right? And then what we are going to do is that we are going to just take the we are going to put up a plus sign, which is a rule, and then you're going to use the first sign, that is f of x, and then we are going to take a multiplication sign, and we are going to find the derivative of g prime of x. So that's all. That brings everything. That is the formula of the product rule. So we just quickly see forward. We're using this particular formula. If we can see an example. So for example, we have got a value, say h of x, whatever it can be, anything, and equals to x squared. And so we put a brace, and then we find 3x. I'm so sorry. It would be x cubed plus 4. X squared, x cubed plus 4. So what I'm going to do is that we are going to take the product rule. So we are going to take this part first. So I will just put it as h prime of x. We can ignore this. We just calculate the values. So this would become as 2x, right? And then we leave this part. That means we have taken this part, right? Then gx is, okay, just for convenience, let me write it as this would be f of x, right? And this part, let us put it as g of x. And then we can make it things easier. So f of x is this one. So we have taken the derivative of the first term, multiplied. So we put a dot sign. So let us put a bracket in between. And then we took the second part, this is this one. So we write as it is, x cubed plus 4, right? We are writing as it is, right? 2x cubed plus 4. Then what is this plus sign? We put a plus sign. Then this f of x. What is f of x? Then again we put it as x squared. Let us put a brace around it for the time being. Then we put a dot, which is this one, right? Then we take g prime x. And what is gx? We are going to take the derivative of this one. So let us take the derivative. What is this? This one would become, as we have noted earlier, 3 would come first. Then we put an x sign. This would be 3 minus 1. And plus 4 would be something like, we can just ignore it. It would be 0. So that is how. Now, if we can solve this one, it would be 2x, x cubed plus 4 plus x squared multiplied by 3x. 3 minus 1 would be 2. We can solve this further as how much of this one, we take it together, it would be 2x raised to the power 4 plus we multiply 4x plus this one, we take it as 3x raised to the power 2 plus 2, 4. So that's it. And we can further solve it. If we want, we can take these two like terms together. If we get 5x raised to the power 4, no, it would be 2 plus 3, 5x raised to the power 4. Right, I think I've made a mistake. This would be 8x, right? So let us make things clearer. So it would be 5x plus 4, this 2 plus 8x. Sorry for this. This would be 8x, right? So that is how simple it is. Yeah, that is the way in which we find the product rule. So let's quickly look for another example. I will make it fresh for you. So for example, we have got an equation, a function like f of x equals to 2x to the power 2 minus 6 and 3x squared plus 8, right? So if you're taking this particular formula, so now just a quick note that you can flip this gx and f prime x and make it again gx, so it doesn't matter the order in which you're doing, right? So if we take forward with this particular formula, so what we get from here is that we mention this as f, right? And for the time being, let us mention this for g, right? So this would make things clearer. So what we are going to do is that we are going to just write it for the time being because it makes things easier. F of x, let us make it 2x squared minus 6. I put a bar sign, there's nothing, just to make a division. And g of x, let us make it as 3x raised to the power 2 plus 8. All right. So what we are going to do is that let's look forward for the formula. So we are going to first find the f prime x and g prime x and leave these two as usual. So what from here, what we can do is that let us find f prime x. This would be how much? So we get 2 and we bring it forward. So 2x, and this would be left 0. So we get it as 4x. Yeah, that's it. And we put another one. So let us find what is the g prime of x. So we do this one as how much it would become 2. Let's see. So we do it as 3 multiplied by 3. Then we get x raised to the power 2 minus 1. Yeah. So this would be roundabout. This would be again 0. So g prime of x would be 9x squared. Right, so f prime x we have found out, g prime x we have already found out. Now what we need to do is that we need to find out the this part. So let us write it once more. So I think it is already written, so we don't need to write this formula again. So we just need to substitute those values. So okay, let's write it for once, becomes clearer. F prime of x, we use this as f prime x gx plus fx g prime of x. So we'll just substitute the values. So f prime of x is 4x. So we get here 4x multiplied by gx. We leave the term as it is. Gx is this one. So it would be 3x squared plus 8. Then we put the plus sign. Then again we write f prime of x, which is 2x squared minus 6. And then we calculate the g prime value. G prime of x, that would be 9x raised to the power 2. Right. So on solving, what we get is that, let us see what we are getting over here. 4, 3, 12x squared, and then we get it as 18x raised to the power 4. And then we get how much? 54x squared, right? And then we get plus 12 raised x to the power 4 plus 32x. So I'm just omitting the immediate part. So from here what we get is, so this one would be 30x raised to the power 4 minus this one would be 54x squared plus 32x, right? So that is how we solve it, the product rule. So just remember that whenever you're getting a term, you can write this as f and g, find the derivatives individually. You can find the derivatives, and thereby you can find out the product rule and do the differentiation. Just one quick note, which sometimes comes as a kind of a confusion which I've seen to the college students, is something like this. Like, you can also write the product rule. Sometimes it comes like, I would use d by dx, and it comes as this one, uv, right? So this is nothing. This is, you can just write it as u prime v plus uv prime. So this is the same as this one. It's the same as this formula, I would say, this one. So it is all the same. So finding, for example, if you want to solve for f of x, so what you can do is that you can just write it as, say for example, u of x dot v of x. So we are going with the same thing. So if you want to find the derivative, so f prime of x, this would be, say, u x dot v prime x plus you put of u prime x and vx, right? And from there, what you can further deduce f prime of x, it would be u x v prime x plus u prime x dot vx. You can even remove those brackets. So that is how. So it is another way you might come across this kind of things in product rule, and because students get sometimes confused by all those u and v star signs. So I just thought to give a quick kind of a revision. So we will just see a few more examples, because this video is meant to give you more examples so that things becomes much clearer. So let us see a few more examples of product rules. So given something like this, d by dx of, say for example, I give an expression 5x to the power 2 minus 9x cubed multiplied by 8 plus x squared, right? So we come across this kind of a thing. So what we will do is that we will again write it as usual. We will take term by term. So what we do is that we take this f of x and we write it as 5x squared minus 9x cubed, right? And we can write g of x as 8 plus x squared, right? So let us find this part first. So f prime of x, what it would be? F prime of x would be, I'm not going into much details of again showing the steps. So it would be 5, and then we will bring this would be minus 5x squared. So it would be 5 minus 9, and then multiplied by 3, and this would be x raised to the power 3 minus 1 would be 2. Right, so we get from here is something like 5 minus 27x squared. All right, so you might be wondering, so this is 1, x squared, the derivative is 1. So what we get from here is 5 minus 27x squared, right? And from here what we do, we take this part, that is the g prime of x. So what we get, g prime of x is 8x squared. So we get 8 would be 0 plus 2x to the power 1. So it would be around 2x. So we got those derivatives, f prime and g prime of x. So what we do is that we'll just find out we'll just substitute the values. So I can write this time as d by dx, because the question is given in d by dx. So I will use this convention. So I can use it as d by dx. And I will write once more, because otherwise things becomes complicated. Fg equals to, I will write f prime of x. See, I'm combining these two things, gx plus fx and g prime of x. Or else I can use the notation also, something like that. So this one, f prime of x would be how much? F minus 5 minus 27 x squared, and I put it in the bracket, right? And then I put it as fx, and gx is how much? So f prime of x, f prime of x is 5 minus 27 x squared, and then gx is how much? Gx is 2. So this particular notation, so we write this, 5 minus 27x squared, then we put this gx, which is 8 plus x raised to the power 2, and then we put a plus sign, and then again we write the f of x, that is 5x squared minus 9x cube, and I'm so sorry for this, this would be 2x, right? So if you want, you can take things forward, or I can just leave like this, because that is how you can find out the derivative. So that basically shows those things. So now, for example, Okay, let me use a new sheet of paper. Now say for example, if I can give you this kind of an expression, if I write it, say if, let's use a condition, and f of x equals to 6x cube 7x4, right? This can also be an expression, and how do we find using the product rule? So what we see is that this is an expression given. So eventually what I can do is that I can find out the f prime of x. We'll do the derivative parts. So this one is fx, this one is gx. So from here, what I can do is that I can find out simply the f prime of x, which will be, how much is the value? Okay, so this would be 18x raised to the 3 minus 1 would be 2. From here, what we do is that we can find out the g prime of x, which will be how much? 28x 4 minus 1 would be 3. Right, so from here what we can do is that if we again use this formula, f prime of x g, I'm so sorry, this is a little bit messy. So if I use this formula, f prime of x gx plus fx and g prime of x, from here what we can do is that we can write how much this is 18x squared multiplied by 7x4. You can see this one, yeah, so the g1 is 7x4, and plus we will write it as 6x cube multiplied by 28x cube, right? So fx and gx, fx is 6x cube and we have found it as 28x cube. So we can further solve it. So what it would be, 18 7 6, also it would be 126x 4 plus 2 6, plus this one would be 648, yeah, it would be 168x raised to the power 6. And if, because we have do both the x together, the like sign, so we can add it and make it as 294x raised to the power, yeah. So you can further solve it if you want, or you can just leave it like this, whatever the way you like. So these are quite nice, easy examples which shows how you can use the product rule. So I will just show you the last one, which will bring a complete end to this video. So how do we use this particular formula? So let us see. If you're given an expression like given, again, say for example, given f of x equals to, say this expression, 3x squared minus 1 multiplied by x squared plus 5x plus 2. Okay, so this part is given to you, and what we are going to do is that simply we are going to substitute this one as fx, this one as gx, right? Clear? So from here what we are going to do is that we are going to find out the f prime of x, which would be, I'm not going through the steps, you can check it later, it would be 6x. And from here, if I calculate the g prime of x, this would be round about, so this would be how much? This constant, so 2x plus 5, right? So now what we do is that, again, if we substitute, I'm not writing the formula this time, so what it eventually would lead to is that we can write it like 6x x squared plus 5x plus 2 plus, I use it at, what is the value, 3x squared minus 1. Okay, so we put it as 3x squared minus 1 and 2x plus 5. So on further solving, what we get, let us reopen it, 6x cubed, this one. Then we get how much? 30, this one and this one, x squared plus 12x, plus what we get is Okay, these two terms, this turns to 6x cube plus this would be how much? 15x squared, right? This would be minus 2x and this would be minus 5. So how much will be the total value? So 6, 12 x cube, 30x squared, and this one would eventually become 45x squared minus 10x minus 5. Yeah. So that actually shows how you can differentiate. So just note it is nothing great or nothing very difficult. So we are using, just substitute always with f and x. Find out the derivative of the f prime x and g prime x, and that actually solves things out. So these are nice little examples which you can try further. You can see how things have happened in the product rule. So these are nice examples. I could have solved this part again, but I'm just leaving it 126. It would be x12 or something. Anyway, it doesn't mind, right? It is just what we are leaving this. This is also the one. This is another example which I showed. So nothing actually to summarize. These are all examples which shows different. This is a kind of a notation which might come across, so don't get confused with this. This is also another example which shows the product rule, the initial one where we substituted those values, and this is also, this is quite simple one. So I hope that you enjoyed the video. A few examples have been shown in product rule. So just watch out my next video in which I would be speaking about sum and difference rule. So more or less the sum rule and the difference rule stands to be the same, right? Thank you very much for watching. Have a nice day and stay safe, and do subscribe to my channel. Bye.